Hey guys, I'm going to go over the last lesson in this unit 3.3 where we've been talking about data. Couple things, this is the last lesson. So this lesson will last Wednesday and Thursday, and then on Friday I'm going to have a review for you guys and then a test as well. I would suggest doing the review before you do the test. I might, try to keep some of the questions the same. The review will be on quizzes like we normally do, and the test I actually just found out we are able to use Unify still. So you guys are used to that. It's a little different how to log in. You're going to do it through Launchpad, and I'll put like specific instructions on how to do that on your own. So let's do this last lesson. Oh, one quick thing. I put my first round of grades in from last week, and it was a little rough, to say the least. If you're going to do any of the Khan Academies after they're due, and remember they're due pretty much every, throughout the week, they're due Friday night. So over the weekend, I can put those grades in, which is what I did. You really got to stay on top of your work for all your classes, including this one. If you're going to do Khan Academy after the fact, though, I did open up that Google form, which the link is on Canvas, Khan Academy makeup assignments. So if you're going to do something after the fact, just fill that form out, let me know. Please be truthful. I don't want to deal with people lying again like before. And then as I go through the week and I see those, I will update your grades. I had a lot of people ask about that. So, okay, let's go through this lesson. I'm going to keep this one really short. Rather than go through the PowerPoint, I'm going to just kind of go over the guide that I did. This one, it's almost like a review a little bit. It's going over a couple new things and a little bit of expanding on all the past 3 lessons. So let's go through this. We're going to describe data distributions. And the way that we're going to describe them is with shape, center, and spread. So with shape, when it asks you, hey, what is the shape of the data? That's where it describes the general shape of the distribution. Is it symmetrical? Is it not symmetrical? Is it skewed to the left and to the right? Or, generally, what does it look like? Center is talking about mean and median, the average and the middle number. It represents a central or typical value of the data set. Again, mean or median talks about the center. In terms of spread, that's where we're dealing with the range, which is the minimum to the max. The interquartile range, or IQR, that's the one where you take Q3 and you subtract Q1. Or standard deviation. Standard deviation, it's a little complicated, but basically it's the average distance between each data point. So it's, here, 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 and then the average. It's a little complicated. We're not going to get too far into standard deviation just yet. So those are the 3 things that we're focusing on that you'll be asked about. So now going over the shape. There are 3 ways to describe shape. It's a skew to the left, symmetric, or a skew to the right. And now this one is a little bit, it's one of those things where it might make sense to you visually or in your head in one way, and in fact it's the other way. So a skew to the left, going this way to the left, you would think all the data is going to be over here, but it's actually when all the data is generally over here on the right, and there's less data points over here on the left. I kind of showed that visually by saying like you start up high and then you go to the lower part, which is to the left. So if you're going down to the left, it's a skew to the left. You'll see that with a dot plot, a histogram, and a box plot. So here we got our highs, we're going low. For a box plot, it's when the box plot is over here to the right, and there's more information, or there's more space over here to the left. With symmetric, that's where there's symmetry. So everything is kind of balanced, you know, there's a nice balance of information here. Histogram, same thing. Everything is here, or where your box plot is directly in the middle. Now, you might also see it where, you know, if I had to draw like a little thing here, where you have something that's kind of like that, where both ends are higher and then the middle is low. That's still symmetrical. It's balanced. You know, same thing with a histogram. It could be like this. There's still symmetry there. Okay. Now a skew to the right, it's going to be the opposite of over here. It's where we have most of our data over on the left, and it's going down to the right. It's going up on the left, down to the right. It's where the box plot starts over on the left, and then there's not as much over on this side. So here's just some other information about that. It's kind of just explaining exactly what I just went over. And so yeah, there's that. So again, skewed to the left, symmetric, and skewed to the right. And that is when we describe data by its shape. So shape is when we talk about the shape of the data. When we talk about the center, that's when we're talking about standard deviation, range, and IQR. These kind of describe each of them. So like I said, standard deviation is the average of the distances between data values and the mean. So range is the difference between the max and the min, and the IQR is the difference between the third and the first quartile. It's kind of like the middle of each middle, if that makes sense. So, you know, if we have our min, our max, and our center, your quartile, your first quartile and your third quartile are right there and there. And then the IQR is the difference between those. Okay. So this one is giving us an example question, and it's giving us a bunch of data here. This is student scores for a third period algebra class, and it gives us to it in order. I've already pointed out the median, the middle, and I've also pointed out the min, the max, and Q1 and Q3, just to explain that a little bit since we're going through this pretty fast. On each side here, we have, besides the median, over here we have, counting the median, which would be right here, right? We have 1, 2, 3, 4, 5, 6, 7. So the Q1, the first quartile, is going to be the middle of the first half, which is right here. 1, 2, 3, 1, 2, 3. Same thing for Q3. 1, 2, 3, 1, 2, 3, and this is our quartile 3. So it wants us, it even gives us a dot plot, which is nice. The first question is asking what is the shape of the data distribution? So it's just asking what shape does that make? It's a symmetric shape. It's balanced. Then it's saying, what is the best measure of center to use? So if we're talking about the center, because it is symmetric, we are going to use the mean. If we're talking about the spread, and remember, the spread describes how data values are spread from the center. That's the range, the IQR, and the standard deviation. That is where we're going to do standard deviation. And I know that might not make sense right now. We haven't really focused on standard deviation too much. So just remember, if it's symmetrical, that means we want to use the average or the mean, and we want to use standard deviation. Now, it wants us to complete the table by calculating the measures of the center. So it wants the mean, it wants the median, and it wants the IQR, which is right here. So to find the mean, the average, we're going to take all the data, all of these numbers, we're going to add them up, and we're going to divide them by 14, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers there. So when I add them all up and I divide by 14, I'm going to get 80. Now the median, I already kind of did that up here. I know that these two numbers are my median. I got to find the average between them, and 80 and 80, then divide it by 2. That's 160 divided by 2, which is just 80. So the mean and the median are the same. For IQR, that's where we take the third quartile and subtract the first. We already found them up here. We have 90 minus 70 to get us a IQR of 20. Basically, it means from here to here, there is a value of 20, 70 to 90. The last question on this example is saying, what do you notice about the measures of center? So why are these the same? They are the same because the data is symmetrical. That's why the mean and the median are the same. If you get something that's skewed to the left or to the right, that's where you're going to get something that probably doesn't match up like this. So one more example, then I'm done. Related to what I was just asking about, in this case, we have a non-symmetrical, so not symmetrical. So here gives us all the data. And now this is for our 5th period instead, so it's a different set. Here, we know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 15 numbers. So either side of 15 would be 7, right? So 1, 2, 3, 4, 5, 6, 7. We know that's good. So 90 is going to be our median. And then we have 3, 3, 3, and 3 in between those. So we find our Q1 and our Q3. And of course, our min and our max are right there. Looking at this data that it gives us, we start up high and we go low, meaning we're going to the left, meaning it skews left. And that's actually the first question. What is a shape? It skews left. The next question is saying, what is the best measure of center to use? So when it's not symmetrical, the center is going to be the median. So if it's non-symmetrical, if it skews one way or the other, that's where we use the median for the center. And for the spread, that's where we use IQR. So the difference between Q1 and Q3. Of course, the next question is, very similar to the last one. It's asking, what's the mean? What's the median? What's the IQR? So the mean, I added up all of these numbers here. I divided them by 15, and I got 82.7. So that's my average. The median, however, is a little bit different. Up here, we already found my median's 90. It's right there in the middle. My IQR, we're going to take 90 and subtract 70. So again, we get 20. So what do you notice about all of this? We know that compared to the other one, the mean and the median are definitely different, and that's because of that skew. It's not symmetrical. We know it skews left. The mean is going to be less than the median because it skews left. The opposite is true if it skews to the right. Students that did worse, so all of these kids, So all of these kids that got 50s and 60s on it, the students that did worse are pulling the average down. If you compare it to this guy here, where everything is kind of spread out even, the average was 80, right? And the median was also 80. But here we saw that a lot of people did well. A lot of people got 90s and everything. The middle is 90, right? But because of these people that got 50 and 60, it brings the average down a little bit. Students that did worse are pulling the average down. So that's the lesson, guys. Hopefully I kept that short. And if you have any questions, I am here for office hours. I had a few people show up today. And think of it kind of like tutoring in a way, because really only like one kid shows up at a time. So we get that kind of one-on-one learning through that. Again, that link's on there. And just make sure you guys are comfortable with this because we have a test on it, just like normal. So if you have any questions, let me know, guys.